In this video, we're going to take a look at the topic 1.4 problem 6. So let's take a minute to look at the problem. It says a sample of a mixture containing an unknown hydrocarbon and some nitrogen dioxide had a total mass of 31.25 grams. The mixture was analyzed using combustion analysis, producing 78.44 grams of carbon dioxide and 32.12 grams of water. So the first part of the question asks us to calculate the empirical formula of the hydrocarbon. So one thing to know is that a hydrocarbon is a substance made of both carbon and hydrogen. And so what we need to do is look at the combustion. We know that a combustion reaction is going to be some sort of C carbon hydrogen compound. We don't know the formula of it, so I just put an X and a Y, plus oxygen, some number of oxygen, and that's going to produce CO2 and H2O. So when you look at that reaction, you can see that all of the carbon in the carbon dioxide is coming from our hydrocarbon, and all of the hydrogen from the water is coming from our hydrocarbon. So we can use that to help us work back from the amounts of carbon dioxide and the amounts of water to find how many moles of carbon and hydrogen we started with. So I'm going to start with the carbon dioxide first. We know that we have 78.44 grams of carbon dioxide. And our first step is going to be to find out how many moles of carbon dioxide we have. So we know that we're going to go from grams of CO2 to moles of CO2, and we're going to use the molar mass of CO2. We know that there are 44.01 grams in 1 mole of carbon dioxide. And then we've got to get to carbon. So we know that for every mole of CO2, that there is 1 mole of carbon. I hope you can read that. I'm sorry. I'll try to make it a little bigger. So 1 mole of CO2 to 1 mole of carbon. And that'll give us our moles of carbon in our original hydrocarbon, because all the carbon here had to have come from here. So when you plug that number into your calculator, you get 1.782 moles of carbon. We also are going to do the same thing for water. So we've got 32.12 grams of water. And then we can go from grams of water to moles of water. 1 mole is equal to 18.016 grams of water. And then we're going to do the same step where we go from moles of water to moles of hydrogen. And in 1 mole of water, there are 2 moles of hydrogen. Okay? So when we calculate that number, that gives us 3.565 moles of hydrogen. So now we can use that ratio of moles of carbon and moles of hydrogen to figure out the ratio of carbon to hydrogen in our compound. So we found our moles. Now we're going to divide by small. So if I divide 1.782 moles, this is my smallest number of moles by itself, that's going to equal 1. And if I come over here and divide 3.565 moles of hydrogen by 1.782 moles of carbon, that will give me that ratio, and that's about 2. So my empirical formula has a ratio of 1 carbon to 2 hydrogens, so my empirical formula is CH2.